Greetings everybody, how you doing? This is Kinesiology 236, Chapter 7. What I did was, instead of going in and using the actual notes from the book and using their slides, I went in and I used the images in the book, and I'm doing my lecture based off of those images. So that's what you'll see here, and you'll notice the slides are white, not color codified like we normally have. That's just a function of making my life easier and whipping through this a lot faster. So when you look at the hand and the wrist, keep these terms in mind. Carpals, more for the wrist; metacarpals, more for the palm; phalanges, more for the fingers. So if you look at this, you have 8 bones arranged, 2 rows of 4. You'll see these, but we won't be quizzing you on these specifically. But you'll see these bones, and you'll see like pisiform, triquium, trapezium, and trapezoid. But you might see hamate as well. But keep in mind, that's the wrist. You go into the metacarpals, that's the palm of the hand, and then you go up into the phalanges. Those are the articulations in the fingers. And you'll see in the book itself, when you look at phalanges, you'll have a different angle here. You'll have different joints, right? So you have the carpals in the wrist. You have, excuse me, the phalanges coming up here, 1, 2, and 3. The metacarpals here in the palm of the hand. So carpals, metacarpals, proximal phalange, middle phalange, distal phalange. Carpals, metacarpal. This is a metacarpal phalangeal joint in between the metacarpals and the proximal phalange. This is a proximal phalangeal joint and a distal phalangeal joint, which separates the 2 other phalanges. Got it? A lot of phalanges, I'm sorry. Radial deviation, ulnar deviation. And in here I left this in for your benefit, but also I provided a video so you can kind of see the difference between radial and ulnar deviation. In the first part of the video, I'm using a wooden dowel to do radial deviation, bringing the thumb up, back down, thumb up, back down. Then I slide the dowel back to do ulnar deviation. And I've done this as an exercise with clients before, and where this has a real-world application, just so you can kind of apply this, would be, let's slide this through one more time. We'll go back to radial deviation. If I were a tradesman and I were to do a bunch of hammering, I'm going from neutral to radial deviation over and over and over again. Neutral, radial, neutral, radial. Got it? Again, left this up for your benefit. Left this up for your benefit as well. By now you should know flexion and extension of the wrist. Also ab and adduction, which looks a lot like radial deviation and ulnar deviation. This flexion of the fingers, extension of the fingers, should be pretty self-explanatory. And then you have ab and adduction of the metacarpial phalangeal joints. I left this in specifically. It's a cross-section of the wrist here. If you look at this, and so often people have an inflammation of the carpal tunnel, and it's just giving an idea of how tightly compacted the musculature, the vascular system, the nerves, and the carpal tunnel is itself, with the bones that are lined up in here. It's actually a pretty tight, compact little area, and you'll end up having people who have soreness in their wrist from doing too much typing, like, for example, the notes for a class presentation for 236. I did this also. I left this up here for your benefit to see. When we look at these pictures, keep this in mind. The thumb is over here, or the thumb is over here. The thumb is pointed to the left of your screen, or is pointed to the right of your screen. This will be a palmar view, or in terms of anatomical position, this is the anterior part of the forearm and the palm. Over here, this is the posterior part of the forearm, and this is the dorsal, or the back of the hand. Anterior, posterior, palmar up here, dorsal down here. So in essence, what you have is the anatomical supinated position, and this is the opposite pronated position. So just keep that in mind as we go through these slides. You'll notice a difference of a thumb position. We've talked many times about the central nervous system, and for the arm, specifically the forearm and the wrist, and into the hand, ulnar nerve comes out of the brachial plexus, crosses the medial aspect of the elbow, runs down through the musculature, down through into the wrist and into the hand. And we know from previous conversation, the ulnar nerve, if someone has dysfunction or neurological dysfunction, in the ring finger, and one half of it out to the pinky or up the side of the forearm, you know that there's something going on in the ulnar nerve. Oftentimes people will do a ton of bench press or tricep extension, and that'll aggravate the ulnar nerve, specifically where it crosses the elbow joint in the medial aspect. And you'll see a downstream kind of background noise into the pinky and half of the ring finger. I left this up for your benefit. You can feel free to review. Going forward, for the rest of these slides, you're going to have color codification. The two color codifications are, if it's a flexor, it's in red. If it's an extensor, it's in blue. So in this example, these guys start roughly page 196, I think it is. Yep, 196 in the book. And you look at flexor carpi radialis, it flexes the carpals on the radius side of the hand. So it originates on the medial epicondyle, which is not unique. If it's a flexor, most of the flexors originate on the medial epicondyle. Here's your thumb, so you know you're looking at a palmar view. So you have the medial epicondyle, flexor carpi radialis comes down, runs over to the radius side, and inserts on the base of the second and the third metacarpals. Okay, cool, got it. So if we look at palmaris longus, that's also used in wrist flexion. That too starts on the medial epicondyle. That runs down into the second, third, fourth, and fifth. So this would be first, second, third, fourth, fifth, right? Metacarpals. And that's basically the thumb out to the pinky. So look at this in terms of how it's named. Palmaris longus, mostly down here in the palm of the hand. Whereas flexor carpi radialis is in the palm of the hand, but only in one specific area. It might be a way for you to remember it. Flexor carpi ulnaris, it flexes the carpals on the ulnar side. Same thing, right? Starts on the medial epicondyle, runs down, also partially on the posterior aspect of the ulna, and it runs down to the pinky side or the medial side of the hand. Okay, and you know this is also in palmar view, and you know that this runs down and hits the hand because it's a flexor on the palmar side. His cousin, right, extensor carpi ulnaris, that extends the carpals on the ulnar side. So it comes down from the lateral epicondyle, and realize your thumb is here. So you're in a dorsal view, not a palmar view, and that's running down from the lateral epicondyle through the medial border of the ulna, and it attaches out here on the base of the fifth metacarpal on the dorsal side, not the palmar side. So if we look at these side by side, flexor carpi ulnaris, you know it's red, so it's a flexor. Extensor, it's a blue in our parlance and our nomenclature. And we talked about how the thumb position matters, but if you look at this, another way you can think this through to help you kind of categorize is, excuse me, you have medial epicondyle, lateral epicondyle, flexor, extensor. Flexor provides flexion of the wrist, extension of the wrist. Is fired by the ulnar nerve, which we talked about on the inside edge of that elbow. The extensors are fired by the radial nerve in general. Okay, so we have different ways we can categorize this, either by the way the nerves fire, where they run, or where they originate. Medial epicondyle, lateral epicondyle, ulnar nerve, radial nerve. So let's carry this through, right? Extensor carpi radialis brevis, it extends the carpals on the radial side, and brevis, meaning brief or brevity, is short. So if you look at this, it can be compared when you look at the other ones. When you look at extensor carpi ulnaris, extensor carpi ulnaris, you'll note how they can be kind of like compared by their name, right? So lateral epicondyle makes sense because it's an extensor, we know that, and it attaches down here into the base of a third metacarpal. Okay, cool, got it. It's fired by the radial nerve. That holds true with everything we just talked about. And anytime there is a brevis, just so you know, there's going to be a longus. And here you go, extensor carpi radialis longus. It extends the carpals on the radial side, and the big difference you have here is this originates on the distal end of the humerus and the lateral epicondyle. So a test question alert here would be true or false. Extensor carpi radialis brevis originates on the distal end of the humerus and the lateral epicondyle. You would say false because longus originates on the distal end of the humerus and the lateral epicondyle, not brevis. See that? So brevis originates over here in the lateral epicondyle. Longus originates on the distal end of the humerus and the epicondyle. And it's run by the radial nerve. Now we'll get back to a flexor. It's in red. We know it flexes the digits, and it's a superficial muscle. And anytime you have a superficialis, you're going to have a profundus that runs in the same party group. And well, it's a flexor, so it's a medial epicondyle, and it's also the radial and ulnar heads, and it's run by the median nerve. Makes sense. Now we take a step further. We go extensor digitorum profundus. Profundus flexes the digits, and its placement is deep to superficialis, and it's also run by the median nerve. So if we look at superficialis and profundus, they're both on the medial epicondyle. I'm sorry, the superficialis is on the medial epicondyle as well as the ulna and the radius. I said that backwards. Where digitorum profundus is on the proximal 3/4 of the anterior of the medial aspect of the ulna only. There is no medial epicondyle for profundus. It only is the ulna. And then when you look further down, this provides flexion of the fingers at the proximal, meaning the closer end of the phalangeal joints, more by the palm. This provides flexion of the fingers at the distal end of the phalangeal joints by the fingertips. And both are fired by the medial nerve, but also profundus is fired by the interosseous branch that runs through the interosseous membrane. Okay. Flexor pollicis longus. Pollicis is thumb. So in this case, anytime you see pollicis is thumb, it flexes the thumb and it's long. So it's on the middle anterior surface of the radius and a medial border of the ulna. Okay, and it fired by the median nerve, which makes sense because it's a flexor. Extensor digitorum extends digits 2 through 5. So you got 1, here's digit 2, 3, 4, 5. And it starts off on the lateral epicondyle, which makes sense because it's an extensor. And it's fired by the radial nerve. Got it. So extensor indicis, think index finger, that comes down and it's firing just the index finger. Again, radial nerve and also through the posterior interosseous branch. Extensor digiti minimi, minimum, think like minimum, smallest. It's extensor, lateral epicondyle again, runs down, hits the pinky. Helps you raise your pinky up when you drink a cup of tea. Extensor pollicis longus extends the thumb. That's the longer version. Okay, got it. And this guy runs all the way down. That's to the distal end of the thumb. Pollicis brevis extends down, but it does not go to the distal end of the thumb. It goes to the proximal end. So the brevis, meaning brevis, brevity, short version. It goes to the closer end, not the further end, like longus. And the other point here is, it originates on the radius while longus originates on the ulna. I just want to point that out between those two slides. You'll see here, originates on the lateral surface of the ulna, and this is on the radius, just so you have that kind of mapped in your head. Adductor pollicis longus, I left this in black instead of color coding it because it primarily abducts the thumb. And when you actually look at this, you look at the thumb itself, and it's fired by the radial nerve, but abductor pollicis brevis, which is the cousin to this, is a thinner type of muscle, and it's intrinsic to the hand, and you'll see that on page 211 in the next slide, whereas pollicis longus is extrinsic to the hand and wrist. I put this up here for your benefit so you can see pollicis brevis and the thinner muscles. And also take a look at these. You won't be quizzed heavily on these. This will be an entire, really, semester of work in here because I can tell you it's very intricate and very involved. But I also left this up for you to review, to take a look at. And I left this up as well, but I won't be referring to this too much. Okay, I have about 30 seconds left. And to that end, I hope you guys are all doing well, and I hope you're having a good little holiday season. A couple of them are all overlapping right now, so I think I'm pretty safe saying have a good holiday season. Please give me feedback on any of these lecture notes or any of the material we've been doing thus far. I'd like to hear if it's good or bad or indifferent, if the message is coming across, if the quizzes are good, if the check for learnings are also good. Be on the lookout for check for learning and an exam. Thanks, guys.